Welcome back. Let's talk about the layer 2 of the OSI model, and let's start with the Media Access Control address, which is also known as a MAC address. And you might or you might not have heard of it, but what is it? Well, to understand what MAC addresses are, we first need to talk about network interfaces. So in your desktop or laptop, you have a connector for an Ethernet cable that we talked about in the layer 1 section of this course. And that connector looks something like this. Although most newer laptops have removed these connectors and they've instead replaced them with adapters that are plugged in via USB or USB-C ports, for example. And these adapters are where layer 1 meets layer 2, and this applies for Wi-Fi as well, but instead of an Ethernet port, antennas are used. Now, MAC addresses are uniquely assigned to these interfaces, whether wired or wireless, by the company that manufactures the interfaces, and therefore they cannot be physically changed. There are some methods to spoof the MAC address, meaning to make it look virtually different than it really is, but we won't cover that in this course. But even if you spoof a MAC address, the burned-in or physical address still does not change. So MAC addresses can be used to uniquely identify a device. And since a different MAC address is assigned to each interface, you can identify a device by its MAC address even if the device is in a completely different network. And that's part of what makes MAC addresses so important. When you're sending and receiving information, you need to use some sort of source and destination address, just like you would to send regular mail, because otherwise the mail carrier would have no idea where to send your letter, and the recipient would also have no idea where the letter came from. And since we're talking about layer 2 or L2 for short, we use a source MAC and a destination MAC to specify that information. Now, we will talk about this and how it works in more depth later, but for now, let's go ahead and talk about the actual MAC address. These addresses are 12 characters long, and they're represented in hexadecimal format, which means that they're represented by a combination of the following 16 characters, all the way from 0 to 9, so that's 10, and then A, B, C, D, E, F, which is 6 more, for a total of 16. So these addresses are created by a combination of these 16 characters that we just mentioned. For example, we could have a MAC address that looks like this. Now, for better readability, it's usually split up in groups of 2, separated by a dash or a colon. So it looks like this. And also, capital letters can be used. So how many MAC addresses exist then? Well, let's do some math. We have 16 different characters, and we have 12 positions. So 16 to the 12th power is 281, 474, 976, 710, 656 options, or let's just say 281 trillion for short. So that's a lot of available addresses. Now, in a MAC address, the first half, which is the first 3 pairs, represent the company that's owning the MAC address space, and then the last half is assigned to each network interface by that company. Let's actually take a look at an example of what I mean. Let's go ahead and open the Windows command prompt, and we'll write out this command of ipconfig-all, or you can also do /all. Now, if I scroll up a little bit after typing this command, I'll find an Ethernet adapter Ethernet, and below that, you'll see the physical address that starts with 40, 8D, 5C, and then it has 5D, B1, 5C. Now, if you don't understand the rest of this information, don't worry about that yet, but on this computer, I'm not using Wi-Fi. Instead, I'm using an Ethernet cable that is connected directly to the switchboard on my router. In any case, I can copy that MAC address and go to macvendors.com to paste in this value. And here it will tell me that it belongs to Gigabyte Technology. The first half of this address represents the company that owns this space, and this is called the Organizationally Unique Identifier, or OUI for short. And if we delete the last half of this address, it will still show the company's name. Now, if we change the values, again, it will still show the right information, but as soon as we change the first half, it will either say that it's not found, or it will show a different company depending on who owns the new range and if it exists. So Gigabyte Technology owns the range of 408D5C-000000 all the way to FFFFFF and everything else in between. Now, if we change the first half to something like CO3EBA, we now see that it belongs to Dell Inc. because they own this OUI. In fact, Dell owns several OUIs. Huge companies like Dell, HP, Intel, etc. acquire several of these spaces since they need to have unique identifiers for each of their interfaces in their devices, whether they're laptops, switches, routers, or anything else that needs to be connected. So now let's switch over to my Mac laptop and see what the MAC address looks like and who owns it. On a Mac or Unix system, we can type ifconfig and we'll see a similar output. In this case though, I'm looking for the ether information to locate my MAC address. And as you can see, now I'm using Wi-Fi and my wireless card has this address: A4, 5E, 60, AE, B4, and 16. So if we copy that and paste it into Mac vendors, we'll see that this space is owned by Apple Inc., which makes sense since this is a Mac laptop and Apple really likes to have control over everything in their devices. Now, since many manufacturers partner with other manufacturers, it's entirely possible that you might own a computer of a certain brand that has a MAC address that belongs to a different vendor, since they probably just bought that adapter from the other brand. So don't be surprised if you see that with your MAC address as you follow along. So this is a little bit about how MAC addresses are created, organized, and assigned to devices. And speaking of devices, let's go ahead and complete this lesson. And in the next lesson, we'll talk about layer 2 devices so that we can start to see how MAC addresses are applied in networks.